So we're just going to go through. There's a bunch of different other types of graphs related to statistics that we're going to go through. And you know some of them already, and then there are some that are going to be new. Okay? So again, if you want to grab each individual graph from your book that I'm going to use in the notes, they're on page 69. If not, you're welcome to take a picture of the screen. First one is a bar graph. And as I told you when we went over histograms, a histogram is a type of bar graph. Okay, but bar graph is more general. They can be vertical. The bars can be vertical. The bars can be horizontal. Okay. They can represent the frequency of the data. For our purposes, that's what it will be. You've seen bar graphs that represent other things besides frequency before. One of the key differences between a bar graph and a histogram is that in a bar graph, the bars don't touch like they did for histograms. And that's a distinction that I want you to make. As I said, here's an example of the type of graph that was in your book that I'm just using. They certainly can be others. This is an example of a horizontal bar graph. Okay. You could easily display the data vertically as well. And then the axes change, but that's an example of a horizontal bar graph. Something called a Pareto chart. Okay, a Pareto chart is a vertical bar graph. It's actually more like a vertical histogram because the bars touch. But you order them. You put them in order from highest frequency to lowest frequency. And it's always highest to lowest. Yes. Okay. Again, here's an example. It's the same data that we just had before, except we've changed it into Pareto chart form. So there's two things about it. One, it's highest to lowest, and two, now the bars touch. Next one is a time series graph. That is a line graph. And as the name implies, it's something that occurs over time. So if time is not one of the variables involved, we would not use one of these. So, again, here's an example. In this case, time represents time of day, not necessarily how many hours kind of thing, since it starts with 12. And unlike a frequency polygon, it does not connect down with the horizontal axis. Okay, it's just a line graph. Pie graph or a pie chart, either one is fine. It is a circle. You know about pie graphs. Okay, it's divided into percentages. So you're actually going to have to calculate the percentages first most of the time, unless you're just interpreting a graph. But when you go to construct a pie graph, you're going to have to take a percentage, and then you're going to have to use some geometry. Okay, because how many degrees are in a circle? 360. 360. So you're going to have to take percentages of 360 and make the central angles of your pie graph match up. And I'm going to talk about how to best do that on the iPad. Okay, but again, here's our example first. Apparently, well, I guess it's likely that the Human Resources Department at Brown's department store would have this information. Apparently half of them are married, 27% are divorced, 5 are widowed, and 18% are single. Now, here's what's important when it comes to creating these on your own. Once you have the percentages, and I'm going to want you to show them because you are going to have to create your own. You're taking a percentage of 360. And that calculation to determine the central angle is going to be important. Now, I don't expect you to hold a protractor on your iPad to try to create those angles. However, there is a virtual protractor which you can find in the App Store that I found very useful, and I would expect that you would play around with when you start to make these. It's called Pencilbox.
I'm gonna download it right now.
Okay, and in a minute I'll show you what it looks like and how to use it, but just know that that's coming, okay? The last one that we're going to look at today is a stem and leaf plot. Anybody familiar with a stem and leaf plot?
Yes.
No, anybody?
Wait, what did you say?
Yeah.
Anybody familiar with the stem and leaf plot?
I did it in middle school.
Stem and leaf. Oh, I did.
So a stem and leaf plot is a table where each leaf contains the last digit of each number. So you have a data set, and the last digit of each data value are the leaves. And we have to tell about the stems, okay? The stem contains the remaining digits. So those are the front digits, right? If the leaf is the last digit, all the other digits in front of that last digit are the stems. The number of leaves will equal the class frequency because that's the number of times those data values will show up. And then the next thing we're going to do is I'm going to give you a set of data. We're going to break it down and I'm going to show you how to create a stem and leaf plot. So here is a set of data. You may take a picture of that if you wish.
It will ruin the aesthetic.
I don't know what this data represents, and to be honest with you, it doesn't matter. The point is I want to demonstrate for you how to create a stem and leaf plot. The key thing to getting a stem and leaf plot together is to decide how many stems there actually are. And since in this problem, other than the number 2, okay, they're all double-digit numbers. They have obviously written the problem as 0, 2 so that it is also a double-digit number. Because again, the leaf is the last digit, and in this case, the stem is the first digit, because all the remaining digits, there's only 2 digits. So the first digit is the stem, the last digit is the leaf, the last digit is always the leaf. What I'm going to do is show it to you organized, so to speak. Okay? So I've broken them up into the groups, the number of stems that exist. So example, there's only one digit, there's only one data value with a stem of 0. There are 2 data values with a stem of 1. There are 3 data values with a stem of 2. There are however many numbers this is of a stem of 3. There are 4 data values of a stem 4 and 3 data values of a stem 5. Okay?
This is whack.
Now, putting it into groups like this is going to be helpful when we create our stem and leaf plot. The other thing that you notice, or maybe you notice, this set of data was already put in order for us from smallest to biggest. Okay? When you create your stem and leaf plot, it's important that the numbers in each group are in order from smallest to biggest. You don't want to just randomly put the numbers for each stem on the line. You want them in order from smallest to biggest. Okay? Now, here's how we're going to start. So you have the stems on the left. 0, 1, 2, 3, 4, 5. Again, if the stems were more than one digit, then there'd be more than one digit. And there's never a gap. You always go from one to the next. Okay? And then what you're going to do is put all the leaves that go with those particular stems, which we've already organized. And you put them on the right side with the leaf, with the leaves. So this is what it would look like. Okay?
Easy.
So the way we read this table is this is 2, 13, 14, 20, 23, 25, 31, 32, 32, 32, 32, 33, 36. Okay?
Oh my God.
That's how we interpret a stem and leaf plot. And so, to Mark's question, what do we use this for? One, it's a more concise way of organizing our data. 2, we can look at it for trends. Where's most of the data occurring? We can find the center of the data fairly easily. okay? And those are things that we'll get into more in chapter 3. And then just lastly, at it with the data next to it, just so you can see it's the same thing. I just put them all on the same page, okay? Most of the time, the thing is, the data's not going to be in order. Most of the time, this is going to be all jumbled up. And you can determine the stems pretty easily and then take that data and make sure you put them in order from left to right, smallest to biggest. And so it's a way of organizing your data a little more concisely. Because think about if these numbers were all jumbled up and not in order at all. You could easily find the ones that start with 0, the ones that start with 1, and then there's a 13 and maybe there was a 14 over here, and you could put them in order that way. And you're going to get an opportunity to do that. Tomorrow, at the beginning of class, I'm going to show you about a back-to-back stem and leaf plot, but you won't have to do any of that tonight. Okay?
Alright.